Welcome everybody to week 3, day 3. I got the lo-fi room background here. So we're going to be learning today about something called separate compilation. Separate compilation is how most real computer science projects run, with exceptions. So one of the big troubles with big projects is that it takes forever to compile it, right? When you are trying to do a full rebuild of Windows, when my friend was at Microsoft, apparently if you just started from scratch and built the whole thing, it's like 18 hours or something. I don't know if it's faster now or slower. I mean, computers are faster, but there's more code. But that might give you an idea of like how long it would take to compile if like you went in, you made a small change, like maybe a bug fix, like an if x is less than 0, some couple simple bug fixes, and you want to test it, compile 18 hours later, try it out. Oh, didn't work. It should be less than or equal to, another 18 hours goes by. Oh, dang it should be less than or equal to 1. It makes development impossible, right? When your compilation time slows down too much, it just becomes like uninteractive, right? And so what people do is they start putting off compiling, right? And they start making change after change after change after change after change, and they try compiling it, and everything breaks. There were several students on the fraction homework that had like 5 or 6 different things wrong, and the error messages get very confusing because it's reporting, you're missing a semicolon here and a curly brace here, and you didn't include namespace standard, and you're like, what's wrong? And the answer is like all of them, except for the ones that are knock-on errors from the other ones not being correct. And so it really is good practice to get into the habit of just compiling and testing and compiling and testing like that. And then you get in the zone and you're writing, you're testing, you're compiling, debugging, and it's all interactive. When you get 18-hour compile times, like you'll make 20 changes and then go home for the day. Come back the next day, see which ones worked. It drastically slows down your compile process. So let me give you an example of Quake. So for example, we got the Quake server here. This is source code to the Quake server. And VCSH for... sure, let's try this. Okay, Visual Studio version selector. Let's do 2019 is fine. And what you'll see in this directory is that there's a ton of .c files. That's C. It's a C programming language, not C++. And so they got a bunch of C programming files. They got a bunch of header files, .h files, and then they got different directories that's got, different things in it. Those are the .o files. They got assembly files here, and basically resource files, source files, Unix, system Unix. So they have a different version of main for Windows, and they have a different version of main for Unix systems, because the way you talk to the world is different. It's like you can't find this include file, right? Because it doesn't exist on a Windows machine. And so this structure, this organization where you've got all these .h files, all these .c files, this is pretty common. And we do this mostly to make the compilation time go faster. The way that it works is that if I were to build this, it might take a while. But after it's been built, it saves the results of the compilation. It saves the results of the compilation into these things called object files. Okay? And that, you see how there's like one of them for each of those .c files? There was prexec.c somewhere. And it might be in a different directory. And there's server send.obj, and there's server send.c. And so what the .obj files are, what those object files are, these things are the results of the compilation. And it's not an executable, it's like part of an executable. And so what happens, it's like a jigsaw puzzle. So when you compile each one of those .c files, it saves the results of the compilation into something called a .obj file, or .o file on Unix systems. And when you go to build the executable, it just takes all of the .o files together, the .obj files together, and goes like this, and assembles the jigsaw puzzle, and that's your a.out. So So the benefit of that is that if you were to compile the code a second time, and you just edited like predict.c, you don't have to recompile all those other .c files. None of those other .o files have to be recompiled. If you edited prexec.c, the only file that has to be recompiled is prexec.c. And that will take your compile time from an hour, let's say, to 3 seconds. Okay? So that's why we, and you know, there's some organizational benefits, like it's nice having things kind of sorted by topics, you know, where is the sprite generator? It's over here, you know. There's benefits to that, but the main benefit is compile time. So let me demonstrate that for you on the server. If you guys remember Easy Peasy from CSI 40, it is a static analyzer. It is a tool that when you run compile, right, when you compile your code with compile, it checks your code for the top 30 most common errors that new programmers make, and they're right here. And I have one .cc file for each one of those common mistakes students make. And if I were to type make right now, it'd be like, it's made, it's up to date. Make is a tool that looks at the timestamps of all the files, and if everything's like up to date, then it says you're done, you're good. But let's say I edit check include. And I'm just gonna, I don't know, do nothing but save it, right? So now the timestamp, if we look at the timestamp on check include, it's been updated to today. The a.out file is from earlier in the day at 12:55 when I did this for the previous class. And so make, which is very intelligent, will be like, oh, check include got updated. So when I type make, it doesn't rebuild that whole thing. Instead, you'll see it just compiles the include file. And it compiles it with what's called the .c flag, the .c partial compilation flag. That generates that .o file. The .o file is the results of the compilation. Okay. And the results of the compilation are saved for all the .cc files. So when you go to build the executable, that makes a file called checkinclude.o, and you'll see it somewhere within this unholy mess here. You will see that all of those .o files get compiled together like that, and that builds the executable. And so if we were to time this process, let me just touch check include.cc. So when you touch a file, that's like you edited it. It doesn't do anything, it just updates the timestamp. It pretends you've just edited the file, makes it nice for doing things like that. So let's build the code, and if you ever use time with a command, it'll tell you how long it took to run, which is nice. In some people's setups, it'll do it automatically if the thing took more than a certain threshold to run. So this took about 8 seconds to run. Okay. See if anyone's eating up my CPU time. Nope. Okay. So whenever you work with make files, there's usually a command called make clean. Make clean erases all of the .o files. So it erases a.out, it erases all the .o files, it usually erases a core file as well. And then if I were to make it from scratch, watch what happens. It's compiling, it's going to compile each one of those .cc files. Compile, 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 compile. And this will take a while. So we will just let that run for a while, and I will put up a new window. Do you guys have any questions about that from a high level? I'm going to show you the low level. Okay, so let's say that we're working on main.cc, and this is how we've been doing things so far. We've been doing everything in just a single file. And it's fine, because our programs haven't been very long, right? Like if I were to make hello world, cout, hi, you know, whatever. If I were to time g++ main.cc, if I were to time the compilation of this, it's taking 0.6 seconds. Yeah, 0.6 seconds to build hello world. On my work computer, building hello world took 11 seconds, which I don't know how Visual Studio is so slow at building stuff, but it is. On my home computer, I've had it take like 45 seconds before to build hello world. I'm just like, What are you doing during those 45 seconds? Because I'm baffled that it's taken you so long to do that Visual Studio. Okay. Could you show us how to solve decompose? Nope. So, decompose is just a for loop. So, if you're going to decompose a fraction, check to see if 1/2 is smaller than it. Check to see if 1/3 is smaller than it. Check to see if 1/4 is smaller than it. You're going to use your less than operator. I actually did this. So I said if I am smaller than the other. So rather than building a temporary fraction, I dereferenced to this pointer, and that gave me a fraction, and I used that to compare it with other. And basically, and returning 1 over n, basically. So n just would increase, starting at 2, going up to infinity. The one trick that I used was guessing what fraction I needed to start with. Okay? So if you have like 200 I don't start at 1/2. Right? Because 1/2 is bigger than it. Right? So if I have 2 101ths, what I do is I do this. So I use... This is why one of those test cases you were failing, because you weren't fast enough. And it wasn't like a C++ trick or an optimizer trick or any of that stuff. It's a math trick. And so if you're trying to decompose 2 101ths, then if we invert this fraction, then we see it's 50.5. So the what do? You sealing it or you floor it? One or the other. And that's so 50, yeah. Or the other way around. One or the other. So I would start at 1/50th, right? Not at 1/2. Start at 1/50th, because it's so small. It's much smaller than 1/2 and 1/3 and 1/4. It's 2 101ths, right? And so I'd start at 1/50th and then go to 1/51st, 1/52nd, so on and so forth. Okay. And so sealing, yeah, that sounds right to me. Yeah, sealing it. So that's it. So basically, using this, you can immediately jump to the fraction or the right neighborhood of the fraction, and find a suitable fraction almost instantaneously. Okay. So that is how you go from order n, where you're testing n fractions less than, starting at 1/2 and working your way down, to testing 1 or 2 or so. Okay. Is there an additional for loop? In decompose, yeah, there's a for loop, but it pretty much finds the right fraction almost immediately, I think. I'd have to think about if it even needed a loop. You shouldn't need a for loop, you just use algebra. Yeah. Okay, so a while loop and a for loop is the same thing. Yeah. So that's the math insight needed to eliminate a for loop. Just be Egyptian. Yeah. I mean, honestly, just it's all right there. Just brush up on your hieroglyphics, and the answer to the homework problem is clearly right there. Okay, so where was I? So you're still compiling. Let's see, are you done? There we go. So it took 2.5 minutes. So to do a full recompile of 2.5 minutes versus 3 seconds. Okay, so it's like 50 times faster. And this is a small project. It's only like 1,500 lines of code. So, okay. Gonna make a quick trip to the pyramids. It's on the back of the Declaration of Independence. That's actually where the answer is. Okay, so let's talk about this. So if we're gonna make a circle class, right? Class circle. Let's go through the rigmarole of making a class. This is a good exercise for you. So what defines what? Do you guys remember what defines a circle? We did this like 2 classes ago. The radius and the point. Okay. So we need a point class, maybe struct point. So point location or center, sure, and then double radius. Okay. Then in the public section, what's the first thing we do when we make a class, when we're doing it the proper way? What's the first thing we make? It's called a convention. No, wait. Constructor. So a constructor. And so a lot of people make a lot of different constructors for their classes. I tend to make just one unless I need to do something like have it import a string or something, you know. So it's going to look like this. Circle, and it's going to take a new center and a new radius. So const. Okay. And I could make a default constructor and a 1-parameter constructor and a 2-parameter constructor, but I'm not going to. I'm going to give default values to these, and do you not like that? Point. What are you mad? Oh, it's mad about you. Should be fine, right? Yeah, okay. So, what's the colon in the middle? This is the shortcut notation. So, this is how you chain constructors together. And you need to do that if you're going to be having const variables. The only time they can be initialized is actually in their constructor. And so what this is doing, it's saying call the constructor on center. So it's going to call points constructor, which is going to copy over the x and the y from new center. If no new center is provided, then it will default to 0 and 0. And it will pass 0 in for the new radius if you don't pass in a radius at all. So it's calling the constructor on radius, which is going to either pass in the value you pass in main or 0 if they don't specify one. So what this allows us to do is we can have a circle bob like that. And this will be at 0, 0, and radius 0. And actually, let's have the radius default to 1. Why not? Just to show it doesn't have to be 0, right? So if we just make circle bob, then it's going to use the default parameters here. If we say circle Pablo and pass in 1 parameter, then this will have Pablo will be at location 3, 4, and radius of 1. And if we say circle Sydney at 3, 4, and 100, then Sydney will be at location 3, 4. Okay, let's make it 3.1 and 4.1, just because these are floating point numbers. They're not ints. So you guys see that? So with just one constructor, I can have a 0 parameter version, a 1 parameter version, a 2 parameter version, and they all work because I use default parameters here. So if you don't specify a parameter, a function parameter, then it defaults to 1. If you leave that one off, and it'll default to 0, 0 if you leave that one off. They have to be left off in order. So if you leave off 1 parameter, it will always be the radius that's left off. It's always the rightmost one that gets ignored first, and then you kind of work your way to the left. If you can't mix and match. You can't specify like the first parameter and the 7th parameter. If you're going to emit parameters, they have to be emitted from the right to the left. So this is 3 constructors and 1. Okay. Radius 0 is an invariant. Yeah, it's probably. I'd probably put in an invariant that radius can't be 0, something like that. I don't know, less than or equal to 0, because then it's a point, not a circle. You know what I mean? invariant. Radius must be greater than 0. All right, so okay, so you can't say circle Charlie 100. Correct. Because that would be skipping the point and not the radius. You cannot do that. You can only skip things from the right to the left. You can't skip, if you have parameters 1, 2, and 3, you can't skip 1. You can only skip 3. So the order that you specify parameters to a constructor thus matters. So if you look at the way the standard library is designed, the third parameter to if you're going to make a vector, vector of, why do I keep using capital V? Vector of circles named vec of size 100, initialized to 20, and then you can actually, if you look at the constructor here, this is the size, this is the allocator. Yeah, so vectors have these things called allocators. It might be the template parameter that I'm thinking of, that nobody knows about and nobody sees except until you get deeper into C++. And the reason why nobody knows about it or sees about it is because they made it the last parameter, and so it just defaults to the default all the time, and you just don't know about it because the default works well for people. But if they had made the allocator the first parameter, then everybody would have to put it in every time because you can't emit the first parameter. You can only emit the last parameters. Okay. So that's how you're able to declare an empty vector. Yeah, and it defaults to size 0. Right. And if you don't specify what value to initialize things to, it defaults to 0 also. Okay. So we've got our constructor. Next up, we need to make a destructor, right? Everybody agree? We need a destructor here? Yeah, no, I wouldn't make it. Nah. Also, to operator equals and copy constructor. Rule of 0. Easy. Easy peasy. No news. No news is good news. I don't see a new anywhere in here. So, yep, we're good. So I'm just going to use the default. Make the comment a little bit more clear here. Use default operator equals and the copy sister. Okay, so then what's the next thing we do? We're kind of reviewing proper class design. We got our private member variables. We got our constructor. Next, we're going to make which functions? Getters and setters, yeah. Getters and setters, also called accessors and mutators. So we are going to have a function that returns a point named getCenter. Is this a const function or not? Does it change the object that it's on when you get its value? Yes, no. Const, yes. Change, no. Ah, yeah, const, good. And this is going to return center, YYP, and you are going to return a double, and you're going to get 6s radius, and then because I did a 6s radius, I can hit dot, and yay, it works. Power of Vim compels you. The power of Vim compels you. The power of Vim compels you. Using the S command makes searching and replacing easy. I actually don't use the Vim global search and replace because I don't trust it. There have been so many times when I've searched and replaced for change an int to a float or whatever, and then all of a sudden main is returning a float now or something. You know, I want to see every change before I change it. If you have a variable named lint, I don't want it called lafloat. You know what I mean? Milady, lafloat. So what I do when I do this kind of stuff is, let's say we got a bunch of things, we had more things. What I would do is 6s that deletes the next 6 lines and does a substitute, and then I don't know, get foo or whatever, and then I would search for radius and hit dot and do it again. And then I'd hit N to go to the next one, and do 6 and do bar, and then N to go to the next one, and dot, and then and to go to the next one, and you know what I mean? Like, so it makes. This is why people who know Vim like literally like can't even when it comes to like using non-Vim text editors. You're just like, wait, I have to type things by hand? Huh? Is this some peasant joke I'm too rich to understand? Like, what? Huh? You type things? Like, no, you type things once, and then after that, you just refactor, you copy and paste and refactor. And yeah, so getters and setters. So void set center, and this will take a const point by reference p, and we will say center equals p, yyp, and we will do actually I'll do a shift R this time. Shift R puts you into overwrite mode. Radius and center have the same number of letters. So, and then dot does the last command that you did. And and this one should be taking a double F. Okay. How did you get yellow highlight color? Front slash. Front slash is the search command. Front slash, and I search for double, like that, and it highlights all of the words double. If I hit return, I have that bound to no highlight, which turns off the searching. So if I search for double, and then I can hit N to go to the next, and Shift N to go backwards. If I wanted to change double to be float, I would do 6S, type in float, and then hit N to go next, dot to swap it out, N to go next, dot to swap it out, N to go next, dot to swap it out, and we're done. That is how I do search and replace. I do not trust global search and replace. Vim has an interactive search and replace functionality where it'll prompt you yes, no for each one. But I like being able to do it manually, because then if I make a mistake, I can immediately hit U and undo, or like go back and like, okay, and then go to the next one. It doesn't seem like the interactive search and replace even saves you very much time, honestly. So Mincarelli's tutorial video is very good. Yeah, it's very good. And he doesn't use Shift R like to overwrite something. He uses insert, which is literally something I didn't know existed until today in the earlier class. I was like, yeah. So it's like I was saying in the previous class, this is why it's fun for me to watch people who know Vim, because it's just like, wait, how did you do that? Because it's so big and complicated. Like if you watch, you know, like YouTube videos like Vim Masters, like they're talking about like all this stuff, and it's just like, I didn't even know that entire field of Vim research existed. You know, you clearly, sir, have a doctorate in Vim. I wish to subscribe to your newsletter. So, I don't know. It's like each person uses Vim, like for a long time. I've been using it. Well, Vim is the new kid on the block. Well, NVim is the new kid on the block. Before Vim, there was VI. And before VI, there was Ed. VI is visual modes. Before that, it was non-interactive. But yeah, I use VI. I've been using it since 90. I used Emacs for a while. Probably 27 years now, something like that. And you know, you build up your skills over time. The thing about S, I didn't know that until about 5 or 6 years ago, where I was watching one of our adjuncts do stuff. I'm like, pause. What did you just do there? You know, because I never understood the S command. Because the S command, if you just hit it by itself, it erases the letter and then puts you into insert mode. And I'm like, why not just hit X and then insert mode? You know, and the reason for that is because you can use 5S and it erases 5 letters, and then you can type in something, and then that, remember, dot repeats the last command you did. So if you hit dot, it'll do the substitution and the typing as one command. So you can hit dot to just repeat your last command. Dot is super useful in Vim. You do that a lot. Repeat the last command, and it can be a complicated thing like 6S, double, whatever. How to get that rail into the left that tells you what's wrong with your code. That is instructor only. Okay, so Mincarelli, I need to take a bathroom break. You want to take over and do a little Vim workshop with him. So I'll just leave this up here, and then let's just pause and take a 5-minute break, and then come back. Okay. It's instructor only unless you can figure out how to use it. So thank you to Mincarelli for providing a very nice introduction to Vim stuff, Vim macros. Watch his YouTube video. I didn't record it because he already has like it's on the playlist, I believe, a 30-minute video on Vim. And what, you don't like my new color scheme? We'll switch it to a more readable one. So yeah, macros are super useful, and anytime you find yourself repeating the same keystrokes over and over again, just say the macro, and the macros will be preserved between launching Vim, so you can. Actually not. That's actually not an unpleasant color. It's actually kind of pleasant actually. Elf-Lord is like kind of a pinkish one. It's like kind of like, yeah, blues, purples, pinks, things like that. Elf-Lord's not bad. Yeah, I've used Elf-Lord before, like non-ironically. Not bad either. Okay, we'll just stick with that one. So Elf-Lord. Delic. No. Evening. Evening's pleasant. I like that. I don't like that like weird gray background though. Anyhow. Industry. Yeah, we'll go with that one for today. Okay. So getters and setters are done. We don't need the rule of 3 stuff because we're doing rule of 0. What else do we need? What else do you need? You're making a class. Now we're going to need the good stuff. What else do you need in a class? Like we got the boilerplate done. We got the class, private member variables, constructors, getters and setters, print function, member functions. Yeah, member functions. So we need to get to the meat of the meat. All right. So what does this class do? What do you do? Okay. And that's where it gets interesting, because all this stuff you just kind of spit it out like after a while. And in fact, for like C-line, a student was saying earlier, you just like select your private member variables and like have it generate getters and setters for you. In C# you can literally just write get set and it'll just make the getters and setters for you, because this is all just kind of boilerplate kind of stuff. But now we're getting to the good stuff. So let's make a Zen function. Bool is n, and it's going to take a point p by reference, and it will be like, yo, return true if the point is inside the radius of the circle. Okay, so we're going to compute the distance, double distance. Let's highlight that. The distance from one point to another is the hypot of p dot x minus center dot x and p dot y minus center dot y. And so that's the distance. We are from the center. We need to include CMath. And are you mad at me? Okay, thank you. I don't get what's like, no. Oh, okay, sure. All right. Okay, you're fine. And then we want to return if the distance is less than our radius, then they are within our circle. If not, they're outside our circle. So we can see out. Let's make a point. Point P, who's going to be at, let's do less than or equal to. It's touching the radius, should be fine. So we'll be at like 4, 4. So it should be outside of Bob, inside of Pablo, and inside of Sydney. Okay. See out dual alpha. Bob dot is np. Pablo dot is np. Sydney dot is np. So if we did our code right, then it should be false, true, and true. Good. Now we're coming to the point of today. We're talking about separate compilation today. All right. So today's topic is separate compilation. So remember what we talked about, like when your text gets too big, it slows down your compile time, right? So right now our compile time is fine. We don't, yeah, like, and this is why up until now in our classes, like it's 0.7 seconds. Yeah, it's fine. It's fast enough. You know what I mean? It's fast enough. But when you start getting into bigger and bigger projects, then you start splitting your files into different source codes so that you only have to compile the little bit, the one file that you've just changed. And so let me show you the process for doing that. In fact, it's here in notes. It's got all the steps written down for you. I'll copy notes up into /public/12822.text. Make it world readable. That's an alias, by the way. And so these are the notes for today. Okay, so what we're going to do is we're going to split this into different files. And a common approach that people take is each class gets its own file. It gets a header file and it gets a .cc file. So it gets what's called a header file and an implementation file. The implementation file being the .cc file. And we do that because, for one thing, it's easy to find your classes. You know, like if you have a class called submarine and it's located within a header file called airplane, like people aren't going to find, like they're going to have to search for it every time. Like, why is it an airplane? I don't know. It's just always in there. It started off by copying and pasting airplane, and we changed it to submarine. I don't know. Yeah, you know, it's like in the standard library. Like, why is tuple in tuple, the header file tuple.h, but pair, which is a version of tuple, why it's in utility? Like, probably something in utility uses it, and I don't know. It just is like, sometimes these things just don't make sense. So what we're going to do is we're going to refactor this code. Refactoring the code is when you take code that works and you revise it to make it more readable, or in this case, we're going to improve the compile time. Let me make the compile. Let me show you just how easy compile time can get to be bad. So if we include cimage, this is the header file we use for doing image reading and writing. This will increase our compile time from 0.7 seconds to 4 seconds. That's just one header file, right? And if we include the entire standard library, that was it, bits slash standard. I rarely do this. It was in fractionation though. CD, CSI, homework, fractionation, don't. Bits, there we go. Okay. So if we include the entire standard library, which you can do with this, I rarely do it because watch what happens to the compile time, right? Oops. There you go. So it went from 4 seconds to 4.7. It's actually not too bad. Actually not as bad as I thought it would be. 1.5. Okay. It's actually not as bad as I thought it would be. So it adds about a second to your compile time. In part, it's because this is what's called a precompiled header. Hey, Matt, what? Compile's fine. What are you mad about? Okay. So, yeah, every time you include a boost, why are you mad? It's compiling fine, so that's COC just flipping out. So high pot, yeah, okay. So yeah, so we're going to refactor this code. All right. And so I'm going to do this by putting point into its own thing and circle into its own thing and splitting circle into an implementation and a header file. So I'm going to do that by copying main.cc into point.h, and I'm going to copy it again into circle.h, and I'm going to copy it again into circle.cc. That. And so when I come into point.h, everything goes away except for the point class. Easy, done, easy header file. I'm going to go into the circle.h. I'm going to delete this point person here. I can delete you. And the only thing I need to know about, well, let's show you what I need to know about. What is the one type that the circle class needs to know about? What do you guys think? Commander of completion is helping you out here. Point, yeah. So it doesn't know what a point is anymore, right? So we have to tell it. Okay, we're using the point.h class. There you go, and voila, it works. And highpot is part of CMath, so let's hashtag include CMath, and there we go. Okay. Now, these things are called. This is a function. This is a function definition. But for short things like this, like little one-liners, not a big deal. Who cares? For bigger stuff, though, you typically want to have bigger functions go into the .cc file. And so we do this. This is something called a function declaration, i.e. this function exists somewhere. That's what you're saying. Okay? So you just put a semicolon instead of the open close curly braces. This is actually a full function. This is actually telling you what the function does. This is simply saying a function somewhere. It's a member function of circle called isIn, takes a const point. Probably this should be a const function, right? Makes more sense to me for that to be a const than not. It exists somewhere. Okay? And that is how we do, and we don't need CMath included anymore either. That's another plus, right? Because what that allows us to do is not have extraneous header files in our header file. So anybody that includes us would normally get CMath included, but because it's only used in the implementation file, it doesn't have that. And so there's this philosophical approach of trying to make your headers as small and concise and readable as possible. Because anybody who includes you, remember, they just copy and paste the entire file into their file. And if you're including stuff, then that gets transitively included. And so the less you can include, the better. Because everything that you include gets included by everybody who's including you. And so if circle gets included by 50 people and you're including CImage, then you're adding 3 seconds of compile time to literally every person who uses your class. And so if you can get away with not including it, it's good not to. It's not inheritance. It's just it's literally copying and pasting something, and then copying and pasting that, and then taking that file and copying and pasting that, and you can end up snowballing how much stuff gets copied and pasted. So you want to keep it to a minimum. Okay, so what we're going to do, let's just try compiling this right now. So we're here in main.cc. Point doesn't exist anymore. Circle doesn't exist anymore. And we are going to include point.h. That will give us access to the point class. You'll see that. Be happy. Watch. See? So by doing that, that's happy. What's your issue? Extra tokens. Oh, yes. Have it. All right, there you go. So yeah. So by including point.h, then all of a sudden we can use point. And that's kind of the mentality you want to have for includes. When you include something, you say, give me the behavior of point. I want to bring in points into my code. You include the point, and now you can use points. And if you include circle, then you can use circles. Is this in circle.cc? No, this is main.cc. Main.cc just got a lot smaller. However, what you will see is that there is going to be an issue. And the issue is this. Circle is including point, and point has the definition for, it's like this, right? It's struct point, right? So when you include point.h, it's literally just copying and pasting these 3 lines in. So it's as if I had just copied and pasted that. And then when I include circle.h has included point as well. And so it starts off like this, right? And now you've got the same definition twice. You violated the ODR, the one definition rule, okay? You can only define a class once. You can only define a struct once. You can only define a function once. You can declare it as many times as you want. If you want to say, hey, somewhere out there's a struct named point, that's fine. Notice that it doesn't get mad at me here anymore. But if you define it, you can only define it once. So there's something called the ODR, the one definition rule. It can only be defined once. And because we've defined it in point and circle, we've included circle, which included point, it's now duplicated. And so this is a very common problem in C++, and it's so common that it has a simple solution. And the simple solution is to put at the top of every header file pragma once. Put this at the top of every header file, and then if you ever try including it a second time, it will not be included a second time, and everything will be fine. Now, you should note this is not standard C++. This is not considered good behavior, but I like it. The reason why I like it is because it's simple. You just throw that at the top of the file, and you're good. You're good. The official way of doing this is saying if not defined, and you have to make up some different word every time for every header file ever. So you typically like include like the name of the header in it. If not defined point h, then you define point h, and then at the bottom of the file you have a hashtag endif. If you screw up any of these 3 lines, then all hell breaks loose. And so that's why I use pragma once instead. Every compiler supports it. It's not part of the standard, but it might as well be because everybody supports it, and if they ever didn't support it, then everything would break. So this is the official way. These are called header guards, and you have to be real careful. Like you know, if you have 1 underscore here and 2 underscores here, not going to work. Everyone forgets the indif. While you're still working on it, it gets mad at you. So I just will use pragma once and let the C++ purists get mad. It's fine. So both of these approaches are in the notes file. So you can either do the proper way, or you can do the easy way. I don't care. I like the simple way myself. But just be aware that people will get mad at you for doing this, because it is technically not part of the standard. But everybody supports it, so it's standard, isn't it? Cope and seethe purists. Any drawbacks for pragma? The drawback, it's not standard. And so it's like using bits standard C++. That thing that I showed you, that's not part of the standard either. So, you know, but that is actually not standardized. Like if you go to Windows machines, I don't think they have it. It's just like a Linux. It's part of the. It's supposed to be an internal header file that you're not supposed to use. But a lot of people just like writing 1 include line and then just not worrying about the rest of the standard library. They just like give me everything in the standard, and then it's fine. If you it has its own Wikipedia page. It's a non-standard but widely supported. Yeah. It serves the same purpose as include guards with several advantages, including less code. Yeah, you don't have to come up with a unique name every time, which can be a problem, right? Like, if you use the same name twice, then you got to come up with another name, and that's, we all know the hardest thing in computer science is variable names, right? So, and then also it should be faster because you don't have to parse the whole file. You can actually open the file, and then the preprocessor's like, nope, primer one's done, and then be done with it. Whereas otherwise, it would have to read through to the end of the file. So it probably is faster, actually. Okay, so this is where other professors would scream at me. Yes. There's several things. I can list them. Using namespace standard, you're not supposed to use. Pragma once, you're not supposed to use. What else do we get meta? Oh, they love inheritance for some reason. We haven't learned inheritance yet, but I'll probably discredit myself to my fellow professors when we talk about inheritance, because I dislike it as a general principle. It makes life easier, and really the only downside is some hypothetical, like what if you go onto a compiler that doesn't support it. Well, I guess I'm back in the 1980s now, and I'm compiling on G++ 1.0, so I would have to refactor all of my code anyway, so, it's like, okay, whatever. Yeah. I mean, if you understand the concept, wow, the hate. Because people get upset. The lower the stakes, the more upset people get. That's just human nature, The most drama I've ever seen in my life was over who got to volunteer for Comic-Con in San Diego. I mean that quite literally. So, I volunteered for Comic-Con for, I don't know, a decade or so. And, who got to be a volunteer for it? It was incredibly, who got to organize the volunteers, who got to put the names down on a list, or factions supporting, seriously. Okay, so what is CircleCC used for? Great question. So remember, circle.h doesn't actually have the function body for isIn. So if we were to try compiling the code right now, in .cc, it's going to be like, you're calling this isIn function, but it's not actually written down anywhere. And so that's where circle.cc comes in. This is something called a linker error. So a linker error takes place when you promise C++ that a function exists, and then when the time comes to make a.out, it can't find it. And then you get this thing. It's not a compiler error, it's a linker error. The code compiled fine. But when you went to build the a.out, it's like, all right, where's this mysterious a_n person that you've been telling me about? And it can't find it. So it gives you a undefined reference error, a linker error. Okay. And you might notice that this is in a file named temp.o. So it actually generates a .o file for you. It just erases it. So if you don't choose to keep the results of the compilation around, it makes a temporary one and then wipes it. So we need to now get into. Let's get down to business to defeat the homework. Oh, I deleted too much. There we go. So there's our function. And our function needs to know about circle. So we say include circle.h. And this person needs to know about cmath. Okay. So that goes away. Now because circle includes point, we know about point, we know about hypot, using namespace standard, and what are you mad about? We are a function called circle : : This is important. This is important. So we are giving the definition of it's const. Let me change that. So, are you still mad at me about this? No, you're just underline. Okay. There we go. So, this is how you do a function definition. Okay. So this is saying I am making circle.isIn. Okay, that's what the colon here means. This is the scope resolution operator, and it's saying I am making the member function named isIn for the circle class. I think that it probably would have even looked like better that way, in my opinion. Like, that's the function we're making, but whatever. So circle colon isIn means we are writing the member function named isIn for the circle class. It returns a boolean, takes a const point p by reference. It's a const function, and here's what it actually does. Now, so can you use namespace circle? There is no namespace circle. I have not made a namespace for circle. It's a class. And so classes and namespaces both use the scope resolution operator. So stud is a namespace, not a class. But this would say use the hypot function. Use the hypot function from the stud class. Okay. So std colon means pick that function from that namespace. This means pick this function isIn from this class. And it looks exactly the same. Okay. And that's that. So now we need to build it. Okay. So we still have a problem where it can't find it. And the reason why I can't find it is because we're only compiling main.cc. If we were to pass in circle.cc here, then it works. Okay? There's one problem with this, though, which is that if we've split our code into 50 different .cc files, if we did a g++, every .cc file, now you're waiting 18 hours again, right? You know what I mean? So we haven't gotten any compile time benefit yet if we compile the code that way. Okay? So what we need to do is we need to do partial compilation. Okay? So what we need to do is save the results of a compile and then use that if it hasn't changed. So we go g++-c, main.cc. -c means compile the file, save the result into a .o file, and stop. So it's called partial compilation, or I don't know, there's other terms for it too. But when you do that, this turns main.cc into main.o. I mean, it's main.cc is still there, right? But it generates what's called a .o file. Okay? And so that is the result. This object file here is the result of the compilation of this. And then when we compile g++-c again, circle.cc, you'll see that we now have an object file for circle.o and main.o. And then if we do this is called the link step. So in the link step, we take all the different object files we need for our executable and we put them together. And then it makes an executable. Voila. And we can run it, and everything works exactly the same as before. Now, if you were to look at like what is inside of circle.o, you'll see that it's got a call to hypot in it, and it's got a definition for the U means undefined, T means text segment, weak reference, I think. And so this function has the definition. The T means the text segment. We have defined the isIn function, circle colon isIn. It is found here. Now, if you were to do the same thing for main.o, you're going to see a lot of garbage. This is all this C in, C out stuff. Somewhere within here, there. So main is calling isIn, and so it has a giant U there, U meaning undefined. So the .o file keeps track of what we defined and what we call. So it defines main. Main's going to be in here somewhere. Somewhere inside of here, there's main. And then it says things that we're calling, but we don't have ourselves, like things like cin and cout and isIn and stuff like that. So pipe through grep main. Yeah. So the T, see, we've defined main inside of, right? We have the definition for main. And we're calling a function called circle colon isIn that takes a point. And so we're calling a function named circle : isIn that takes a point, and by reference, and is itself a const function. And so what happens when you do the link step is that it grabs all these .o files and says, okay, all right, so main, you're calling this isIn function. Has anybody seen it? And circle's like, I got it over here. I've defined it. Okay, cool. And then it's like a jigsaw piece. It goes, and then like maybe circle's calling high pot. It's like, all right, does anyone know how to get high on pot? And Standard Labs is like, I do. STDs and high pot go together really well. Okay, cool. And then that gets clicked in. And so all the people and all the things they call, it's like a giant jigsaw puzzle. And all the linker does, it goes, oh, there's you. Okay, in object file number 5, you've got that thing, and you're calling that one. Oh, it's found over there. And it just goes and puts it all together and makes an executable out of it. And so then you get a.out. So how is this faster? It's not if you're doing it like this. You know, if you have to build it by hand and you're like G++-C and like forget about it. So what we do is we do something called a Makefile. And a Makefile teaches the system how to build your project. So let me do a make clean. And if I type make, what it's going to do, it's going to use this Makefile. And these are the things that are output. Like it's making a.out. It's going to make a file called main.o. These are the targets. That's what they're called. It's going to make a file called circle.o. It does not make a file called clean. Clean doesn't have any dependencies, see? So it just erases all the stuff in the directory, all the .o files, stuff like that. But basically, you give a Makefile a series of targets and dependencies. And so what this means is that we build a.out using main.o and circle.o. Those two things are the things we need in order to make a.out. And so when you first run the thing, it's going to look to see if main.o and circle.o exist. If they don't, then it's like, all right, hang on. What does it take to make main.o? Okay, we need a file called main.cc. Does main.cc exist? Yes, it does. Okay, sweet. Then how do we get from here to here? Like, how do we go from a .cc file to a .o file? Well, you do G++-C main.cc. That takes the cc file as input, gives a .o file as an output. All right, cool. Main.o came out. Sweet. What else do we need? Oh, we also need a file called circle.o. Okay, cool. And then what does circle.o require? Circle.cc. Does that exist? Yes. Okay, awesome. How do we go from here to here? Okay, we do that. All right, sweet. It build. All right, sweet. Awesome. Do we have both these files now? Yep. Okay, cool. So how do we go from these two files to a.out? Well, we link them together like this. G++ is smart enough, by the way, to look at the extensions of the files and to know whether it needs to do the compilation step or the assembly step or the linking step or whatever. And so if you pass G++ a bunch of .o files, it will invoke the linker. The linker is called LD, which you will see right here. This is the name of the linker. I never call it directly. I just be like, yo, link these two bad circle.o. Okay, they don't exist. All right, well that link those two bad boys together. All right, make. And so make will look at the dependencies and be like, all right, the first thing we need to do is build main.cc. The second thing we need to do is build circle.o. Third thing we need to do is link the things together. We got a.out, done. Right? That's way easier than doing this all by hand. G++ main.cc. No, like we don't do this by hand. We use Makefiles to automate this process. Now here's the cool thing. You can add an optimizer, sure. If I hit make again, it's like, nope, you don't need to do anything. Oh, cool. Now if I come in and I make a change, and I like, I don't know, just add some random stuff or something, save. If I type make, watch this. You were asking, how is this faster, Shook? Watch. When I built it the first time, when I did a clean make, it compiled both main.cc and circle.cc. Watch now. See that? It knew main wasn't touched, so it doesn't need to recompile it. Right? So if you have, for this, it's trivial. It's only a short compilation anyway. But imagine you had 50 source code files, right? Like my project, which had 30, it took up to 2.5 minutes to build it, right? I don't want to wait 2.5 minutes every time I want to recompile my thing. I want it to take place like this, you know? And so by using a Makefile, when I make a change and hit build, it rebuilds in 2 seconds instead of in 2 minutes. Okay? And so that allows you to quickly iterate, to quickly make a change, test it, Oh, that didn't work. Go back in, edit it again, save it, make, run it, test it. Oh, it worked. Okay, let me do something else. And that keeps you in the zone. It keeps you working. It keeps you flowing. When a build takes 2 minutes, you lose your train of thought. You get bored very easily. You start checking Reddit, and then the thing finishes, and you're just like engaged with some argument with somebody online. You know, your workday shot. I used to work on a project where, unfortunately, the critical file that everybody included, that everybody depended on, had bugs in it. And so I was constantly editing it, and every time I edited it, it triggered a full recompile. And it was like hours. It was like a 2.5 hour rebuild. And every time I touched that damn header file, it triggered because everybody used it. It was the common project header file, and it's like, all right, I need to add a new, score or whatever that everybody's gonna be able to read and write from, like this global scoreboard or whatever. All right, I'm going to the break room. Boop, hit build. Went to the break room, grabbed a newspaper, came back. Oh, damn it, I misspelled it. I call it scorebird. Change the name. Compile. Go back to the break room for another 2.5 hours. I got to know that vending machine really well. It's not stressful, although my manager would come and he's like, "What are you working?" I'm like, "I'm compiling right now. I'm sorry." Like, what are we paying you for? Like, yeah, I know. Yeah. So then I started like billing less hours, and then they're like, "No, don't do that. If you're here, you need to bill those hours." You know, because I would only bill like 3 hours for a day's work because I felt so bad about it because I'm not working most of the time. I'm just sitting in the break room drinking coffee and eating, vending machine cinnamon rolls. Are they compiling chats for programmers? Yeah. So Discord and Slack and things like that, where people, yeah. Like, and if you work for a professional company, you will be on these chat channels like constantly. And while you're working on it, your Discord or Slack or whatever is scrolling up, and you kind of keep an eye on it and give your feedback and stuff like that. Yeah. But that was a bad week. When I was getting that thing all shaped up, it's just like, I'm just gonna go home. Shut down the machine for me at 5 o'clock, will you? Hit build at 2. I'm like, I'm just gonna go. It's gonna finish at 5:30. So, yeah. So that is how it works. This file is called Makefile. It is with capital M, and I will make it from scratch for you. Capital M, right? Not lowercase m. And so the format is target, dependencies, and then how to get from the dependencies to the target. That's that, and you notice the tab there. Vim will do that for you. It'll put the tab there. If you don't have a tab, it isn't a Makefile. Okay. So you always start off with your main target. The main thing that we're going to build is something called a.out. A lot of people, they'll build executables with actual names, like real people. And so they might call this like circle test or something like that. And circle test depends on main.o and circle.o. And in order to go from main.o and circle.o to circle test, do you guys know how to do that? So that'll build the executable. How do we get an output name of circle test? Anyone know the flag? -o, circle test. So that will build an executable called circle test using main.o and circle.o. Okay, well, how do we get this main.o fellow? Well, main.o depends on main.cc, and we get it by g++-c main.cc. Ditto for circle.o. That depends on circle.cc. How do we get there from here? Same as above, and then we usually make a target called clean that has no dependencies. That means it's not like a real thing. But if you type make clean, then it cleans up the directory. Sometimes you screw up your build, right? Like maybe you change the date on your machine, and all the timestamps are like all screwed up. Sometimes you change a header file that everybody needs, and then you have to do a full rebuild, like in my situation. Sometimes you switch compilers, and if you switch compilers, like if you turn address sanitizer on or off, like you have to usually do a full rebuild. And so it's not G++, it is remove all the .o files, and it's force remove all.o files, a.out, and core. So core files are created when your code crashes. A.out is your executable. Str.o is all the intermediate files, all the object files. And F means don't prompt me, shut up about it, just do it. So now, with that, we can type make clean and make, and that's a full rebuild from scratch. You can see it's pretty fast. And if we were to edit main.cc, touch, by the way, simulates, again, editing a file. Look, when we compile it, it only compiles main. It doesn't compile circle. If we were to edit circle.cc and update it, when we type make, it only recompiles circle. It doesn't recompile the rest. And so if you've got 50, if you have 50.o files in here, it'll only build the file that you just touched. And then it will do a link step linking all those .o files together. Okay. So it allows you to actually get your work done. Makefiles are industry standard. Make clean is a standard thing that you will see everybody have. There are things that generate makefiles that there's like CMake and there's auto tools, and which is kind of old. And then there's more better, maybe better is kind of a suspect word, but like Meson and Conan and things like that that are trying to take building C++ projects into the late 1990s. Because C++, the one genuine criticism of C++ is that building their projects is kind of stupid. So, yeah. Is this how you make input tester? No. This is how I made the input. Well, this is how I made the makefile for your last assignment. If you go into fractionation and you look at the makefile, it's very simple. It just compiles do.edit me.cc. You type make. It makes a.out using two files, do.edit me.cc and fraction.h. If you edit either of those, then it will rebuild using C++ 17. And so you can put your command line parameters there. I think somebody asked, like, is this where you can put the optimizer? Yeah. In fact, in the public directory, Vim, let's try that. In the public directory, there is a sample makefile, and this is actually a really good makefile that it'll, assuming all of your files are part of the project and they're all named .cc, it will build your project for you. So it will use every .cc file as a input file, and it'll build a .o file with the same name as the .cc file, and it'll use all the .o files to build the a.out. So this is a general, you can just drop this makefile into any directory that has a bunch of .cc files, as long as you don't do something like have main and like old main and like old main copy and old main copy that each have a main in it. If you did that, this would break because it tries just combining them all together. Assuming that you have a, well, you know, like one .cc file for each, you know, like no duplicates and things like that, this makefile will actually work very well. And there's also a simple makefile that just has an example of like having a debug and a release version of it. So you can do make debug or make release. This is also another kind of industry standard thing. When you do a make debug, it'll turn on the safe standard library, turns on debugging information, turns on asan, the address sanitizer, turns on ubisan, the undefined behavior sanitizer, turns on the debug hashtag define thingamabobby that some things use, then compiles your code that way. Whereas if you type make release, then it turns on the optimizer. It does a hashtag define release. And so you can have your code run differently in debug mode or in release mode. Like in debug mode, you might have cout statements. In release mode, you don't. And so you can just build your code. You can type make debug, make release, and then it'll build it either with one set of flags or the other. That's very common too. Great old main. Yeah. So you only make a CC like circle.cc if your class member function is long. Yeah. Some people will do it for every member function. And so you'll see like, you know, double circle : get radius const. I don't like doing this simply because you're duplicating so much work. You know what I mean? Return radius return type out of line, and see if you don't type it exactly the same way. What is different here? If you don't type it the same way, oh, it's a float instead of a double, right? And so if you refactor one file, then you have to now refactor the other file and keep them in sync with each other. So if you change the name of the thing in the header file, you have to change the name of the thing in the implementation file, and I find that very annoying. And remember, there's no difference. Like it's not like the code behaves differently when you do it one way or the other. It's going to behave exactly the same way. The reason why we go through this rigmarole is just to speed up the compilation time. And for something like this, like, it's 2 words more. You know what I mean? Your CPU runs at 3 or 4 gigahertz. Parsing an extra 2 words. Like, if you care that much about it, like, take out your functions, the comment that says function definition, right? Like, take out that, because that's as much text as it has to parse here. You know what I mean? Like, strip out these guys if you're at that level, right? So I don't like having short, and people will disagree with me on this, Mr. Finn. They, like, when I took this class, everything went into the .cc file, and so you would have up here, point gets center const, semicolon, and then you do it in the .cc file. Okay. And then you would do it. All the things would be down here in the .cc file, and there's no point. There's no point. These 2 words aren't going to, you're never going to measure a compile time speed off that. Just throw your comments away if you care about that. Okay, but yeah, long functions, you want them in the .cc file, because remember, the whole point of this is to speed up compile time. We're trying to you want your header files kind of as small as possible, right? And if you don't, then you end up with like cimage, which is which is 65,000 lines of code, right? That's why it takes 3 seconds every time you include cimage. This is why it adds 3 seconds to your compile time, because all of this is in a header file. And it's got a lot of stuff in there that you don't even use. Like, there's stuff in there for Windows, and stuff in there for Linux, there's stuff in there for handling mouse clicks, there's stuff in there for creating windows, none of which matter on a terminal, like we use it for. All we use it for really is for opening and saving files. You open an image, save an image. You see they got all this stuff for they support 3 different operating systems. And so we could literally come through here. It's kind of a summer project I've wanted to do, which is to just kind of like come through here and just purge from cimage everything we don't use, and just have that sort of minimal subset that's needed to just, because like I don't need all the other stuff. Like they have image filters and stuff like that in cimage, and they're slow. Like if you use the cimage like darken function, it takes like 9 seconds to run a 4K image, whereas when I do it, it's like a second, maybe, if that. And then if I code it in assembly, I can get it down to like 30 frames a second, right, to process a 4K image. And like, it's not even worth anything, really. I mean, I'm sure there's a lot of work on the author's part, and it's a good header file. I mean, I like it, but man, all this stuff in here, it's supporting different architectures and all that's necessary from his perspective. From my perspective, it's terrible because I don't need it. I'm not on an ARM system. I don't need Windows support. I don't need the ability to have any graphical interface stuff because we're using it on a terminal, right? And so, I kind of want to do a project where we just go through and just pull out the useful bits of cimage and just have a function called like open JPEG and save JPEG. Open JPEG gives you a 2D array of red, green, and blue values, and save JPEG takes that array and spits out a JPEG file. And that's it. That's kind of what I want to do. And then rather than taking 3 seconds, it might take half a second. And that's a lot more palatable to me. You can see here I built a precompiled header file. So precompiled header files are like .o files, but for header files. If you ever do this, G++, and don't do this, by the way, circle.h, yeah, it's fine. Then it will generate something called a precompiled header. You can see this thing's like big too. It's like, actually, let's unalias plus clean make and G++ circle.h, and you can see, yeah, it's gargantuan, right? ls lh. Like, we have a header file that's 688 bytes, and when you save the precompiled header, it's 2 megs somehow. And so what this, though, is it's the results of the parsing. So basically, the compiler will parse the header file and kind of write down what it was like after it read it. And so anytime you include circle.h, then if there's a precompiled header like that, it'll use the results of the precompiled header and not need to include it again. That's how including bits was so fast. They made the entire standard library into a precompiled header, and then you can actually include the entire standard library very quickly without needing to parse all of that code, because they saved kind of the results of the parsing. Maybe C++ will be like JavaScript, Python someday, where you just include what you need. I mean, that's kind of what it is right now, right? You just include C math or whatever. And I actually think the future, and nobody's talking about this is just my own personal idea, is actually to use a database to do compilation. I think the entire system we have right now is stupid. I think it's frankly dumb. If I change one function inside of, like if I let's say I had 100 functions inside of circle.cc. If I change just one of the functions, right, like a true to a false or something like that, it still has to reparse and recompile that entire 100 function version of it, and that involves copying and pasting the header files in, and you could be talking about 7 seconds, 10 seconds, and you don't need to, because all the includes are the same. 99% of the time, your includes don't change. 99% of the time, the other functions don't matter at all to you. The only time they would matter is if they do something terrible, like hashtag define something that you then use. So this wouldn't work if you do a lot of preprocessor macro stuff. But I think honestly, the future of compilation is databases. You store the results of every compilation into a database. So the function circle : is in, the results of this would get saved into a database. So the .o file for just this would get saved into a database. And then when you go to build it, you start with main, and main's like, I'm calling these functions. And you find them in the database, and if you don't find them, it's a linker error. If you do find them, you pull them in and see who they called. Oh, we're calling these two guys. Okay, pull those in. And you just have everything in a database, and it's just a quick database lookup. Nothing ever needs to be recompiled ever, except when you actually come in here and, change a less than to a less than or equals or something like that. Then you don't even have to recompile the entire file. All you have to recompile is just that little block of code. And again, this won't work if there's like people doing things like up here, because inside of another function you could do something terrible. You could be like define dist to be cout, right? And now cout is equal to, you know what I mean? Like, as long as you don't do terrible stuff like that. So it would be not C++ conformant, because preprocessor stuff is a part of the language. But I think that would radically improve build times, like radically. Should each function go to a separate file? No, because at a certain point, let's say you had 5,000 files, one for each function. Every one of those files is going to have an include for all of its stuff. And so you're going to get into a situation where when you do a make clean, it's going to now take you 100 hours, because each one of those files has to still include circle. Circle still has to include point, and point still has to include cimage. And so now a full rebuild is going to take you 5,000 times, whatever, 10 seconds, let's say. And it gets dumb, because you do have to do full rebuilds occasionally, and so you get to a point where like the overhead of including things over and over again becomes worse than the the recompiling amount, the amount of code you recompile. Let's put it that way. So some people will do Unity builds where it's the exact opposite of this. Like they'll do something terrible. Like they'll do hashtag include like circle.cc. And look, it works. It compiles. Don't do this. Like if you're doing separate compilation, this defeats the entire purpose of separate compilation. What this is doing is copy pasting all of circle.cc here, and then circle.cc is including circle.h, which is going to be here, and circle.h is including point.h, which is going to be here. So we're actually right back to where we started with our original main.cc. There's going to be no benefit in compile time. The only benefit is that you don't have to include, cimage in every file. It only gets compiled once. And so some people actually refactor their code to become a Unity build like this, because sometimes the cost of including all those files repeatedly, like if you have 100 files you include in 100 files, that's 100 times 100, right? And so your full rebuilds become very painful. Whereas if they're only in a single file, then you only have to include those 100 header files once. So it's a trade-off, and there are people called build engineers who just mess with this kind of stuff, trying to improve build times. And then that's not even getting into like testing and integration and all this other kind of stuff. So pragma once comes into play here, because I'm including point.h and circle.h is including point.h, and so point.h would be included twice. And because we have pragma once on here, it doesn't. It only appears once. Pragma once prevents a file from being included multiple times, and so it preserves the ODR and basically just makes things work the way you think it should work, and it's just good to go. What would be stored on the server? Not even .o files. I think it'd be just the object code for that function. Like when you look at what goes inside of a .o file, there is the actual function here, and that would be, this entry would be in a database. It would be searchable by its signature, and then when somebody tries calling this signature, circle : is in, passing in a points by reference, const reference. That's a const method. Have you heard of this? Yes, I have. Where is it? Here. And it would just pull out that object code for you. That's my doctorate thesis, because I've never seen anybody talk about that. And I honestly, like, after dealing with all these build issues and things like that, it would be so much faster. Like, there are these things called caching compilers that cache compilation results, and as a result get enormous speed ups. Because if you think about it, most of the time you're just wasting time. When you build your code, 99% of the work you're doing is the same as what you did before. And that bugs me, especially when you're talking about 14 hours of your life, or 2.5 hours of your life, and you're banging your head against the table in the break room because you're eating vending machine cinnamon rolls for the 100th day in a row. Do you think you could ever make that type of compilation system? I've been thinking about it. So, I don't know. We'll see. All right. So your next homework assignment is going to be, first of all, any questions about separate compilation? The notes for today I posted onto the public directory. Yeah, it's not going to work for a lot of C++ code, because a lot of C++ code has weird preprocessor directives and things like that. But I think it's got promise. So yeah, thank you. It's been something that's been kind of percolating in the back of my mind for a while now. Kind of like readlib. Like readlib was percolating in my head since the 90s, and I finally got around to writing it a couple of years ago. So, do you want us to do the labs for Zybooks? Yeah, sure, why not? Okay, so your next homework assignment is called Imaginary Homework. And imaginary homework is basically talking about complex numbers. And so I've already done the skeleton for you. I've made the Makefile for you. By the way, if you wanted to add like optimizer, you could like put a -03 for each one of these things here, like that. There's a better way of doing it, which is to use a Makefile variable, which looks like this. And so in Makefile speak, that makes a variable, and then these are the flags that get passed the compiler. So it's turning on debugging, optimizers turned on, using the C++ 20 standard with all warnings and extra warnings. And you can see you use the variable like this. And so I like doing one variable so that all my compile options are the same. I don't like doing it by hand. I don't like this, because you kind of want all your compile flags to be identical. Okay, so for this homework assignment, you're going to be doing complex numbers. And a complex number, if you guys remember from math, is something like 3 plus 2i, something like that. And yes, you do get more math. One more math assignment. I'm working on your next assignment, not this one, the next one. And I told you it's going to involve rectangles, right? So it's going to involve rectangles, and it's going to be involving games, things like that. It's actually going to be game engine stuff. So heartbreak. Read my professor be like, he does too much math theory. Yeah, you got to balance them out. You got to balance them. It probably seems like I'm like all like salty about that. I'm not. It's just hilarious to me that a student would complain about their professor, talking about video games too much. I don't know. I'm a game development professor. I like video games. Like, to me, homework assignments where you're making a video game are more interesting. But be careful what you wish for. Yeah, you get zeta, you get fractions. Now you're getting imaginary numbers. It's not actually deliberate. The zeta assignment came up just because I was up at Shaver before the semester started, and a former friend, well, we were in the department together basically at UCSD. She was telling me about the hardest class she ever took. I'm like, my students can do at least this little bit of it, So that was kind of where the zeta came from. And then both fractions and complex numbers are very amenable to using operators, right? So for this one, you're going to be doing even more operators than before. Comparison, multiply, minus, right? And so you're going to learn how to make a type that behaves mathematically, okay? And in order to make the complex class, you need to make the imaginary class first. Okay. And then you'll use the multiply and such. By the way, the word imaginary, you see how it turned green? You actually can't use the word imaginary in a C++ program. That's why it's called imagine, and capital I imaginary. It's a reserved word in C++. Will we have to pass all tests? Yeah. The way the points work in this class is the number of tests you pass, the points you get. So, yeah. So this one has, I think, 20 test cases? No, there's no extra credit on this one. It's just, this is only a 10-point assignment, but there are 20 test cases just to make sure you get extra coverage, test coverage. Okay, so, yeah, he just likes math so much. Yeah. To each their own. So the complex numbers, do you guys remember those from algebra? Like, you got a real part and an imaginary part, and when you add them together, you add the real parts together and the imaginary parts add together. When you multiply them, you do FOIL first, outside, inside, last. And so in order to get all that working, you have to have your imaginary number class done first. Because if you multiply two imaginary numbers together, you get an integer. And if you multiply an imaginary times an integer, you get an imaginary. So you need to do those first. So you need to do the imaginary class first, and then that will enable you to do the complex class. So that's the order of operations that I recommend you doing it in. You kind of need the imaginary going first. And so you're gonna do two different. You guys see this? There's two different star operators. An imaginary times an imaginary gives you an int, and a int times an imaginary gives you an imaginary. 2 times I is 2i. I times I, -1. And that's about it. It's not too different from what you did with fractions. There's nothing as hard as decompose in it. Yeah, it's just all the skeleton is in there, and you can see they got the colons. I'm doing this like my old professor's way, right? Everything is in the .cc file. And so some of these are done for you, like the minus operator is done for you, so you can kind of see how it works. You can use this as like a model for making your plus operator and stuff. It'll be due in a week. It's always due in a week. But in the meantime, work on the books as well. That's due on Monday. So the double left arrow, the double right arrows are done for you. Most of these, though, that's a placeholder, right? So anything that says this function is functional is done. Everything else is a placeholder, right? So it's a placeholder just to get the code to compile. So you want to start off by testing your imaginary, making the imaginary class work, test it, get it working, then start working on the complex. And after you do that, probably the hardest part of the assignment is the exponent. So this is the one that gives students a headache. How do I exponent a complex number? 3 plus 4i to the 10th power. So everything else is pretty easy. There's examples, plenty of examples. You need to do the constructors. Yeah, so the double left arrow and the double right arrow aren't done for you for complex, but it is done for you for imaginary. So take a look at that code and use it here to figure out how to do it. Okay. Video in the link list sounds great. Yeah, so Makefile, if you want to put together a little thing on linked list, we'll be studying that in the future. But if you want to put a little review on it for them, that would be nice. So that's it. Have a great weekend, and make sure that you get the books done by Monday. Okay. And please give a warm applause emoji for Mincarelli for being awesome as always. And sorry about the thing earlier. What are you talking about? Oh, you just couldn't hear me, dude. It's fine. It was just funny. I'm like kicking my ETA. No, please. Yeah, no, thank you. Thank you. That was awesome. I was just sitting here listening to you for a while. Yeah, and so if you guys want to ask me curly questions about linked lists, it sounds like he's going to make a video for you or something. So that's pretty cool too. All right, so that's it. It's the weekend. Am I going to go skiing? I don't know. We'll see. See how it goes. Hopefully conditions are good. All right, peace out, everyone.